All right, you guys, I finally went and got one. The big engine, Penzi S1. This happens to be the old Lionel TMCC one from around 2000 to 2001, and of course I got it in need of some help. So we got a couple challenges right now. It's mostly all stock, I believe. It's got the original Odyssey board in it. Cosmetically in pretty good shape. A couple little things to fix. But right now the IR tether isn't working correctly. So it's kind of a homemade job here. The original owner put this nice short IR tether assembly in here, but it needs to be redone a little bit so the IR LED and the receiver are more in line. But as you can see, it's in pretty good shape. It's a big engine. I mean, it really is. It's kind of over the top, I think, but I couldn't resist. The price was right. I think the guy owned it for a while, just cleaning out his collection. And since it needed some help, I got an okay price on it. So let's get it into the shop. And the first thing I want to do is see if I can come up with a fix for this IR tether so it's reliable. Okay, so here's what our homemade IR tether looks like right now. And you can see the IR LED. This was not the original S1 drawbar, so whatever it is, it works pretty nice because it's nice and short, but there's no enclosure for the LED, so there's no good way to keep it aligned. There was like a bunch of tape and stuff on there holding it together, but this has to point out that hole, and then it also has to kind of step back behind this little groove here so that the tender drawbar can connect. So I'm going to bring the tender in here and just demonstrate that this does work, but it needs to be like pretty perfectly aligned. All right, so here's our IR tether kind of hanging in free air right now. You can see the LEDs hanging there, and we're responsive. You know, if I run the engine, I got the sounds turned way down low, but hopefully you can hear this. When you misalign these guys, you'll get this rapid clicking. Let's see if we can hear it. Yeah, there it is. I have the sound turned down so you can hear me talk. But anyway, I was trying to fool around with this and just see how sensitive it was as far as picking up that IR LED. And it's actually pretty forgiving. So I whipped up this quick print for the IR LED holder box. So this is the first pass. I'm gonna just fit it up and see if I'm even close. All right, so here's the little house that the IR LED is gonna live in. And it's kind of a copy of what Lionel would have done at the time, just a big plastic box to hold this guy steady. And what I ended up doing was I made a box with a hole across it, and then there's a hole pattern underneath, and you can see that, to bolt it to the drawbar. I put this little wall in here with a 3mm hole in there just to nestle the LED. So not too bad. It was a quick print. It was like 8 minutes. It only took me 2 shots to get this. I don't think I'm going to mess with it anymore because it's working now. I'm just going to tidy up some of the wiring. Okay, so what's going on here is I got a little intrigued with the old Odyssey in here. Now, I wasn't aware, but this did have like the 2nd generation Odyssey where it was an on-off system. And it had a slightly different speed curve compared to the earlier versions that came out in like 99 and 2000. So basically how it works as a closed loop system, this magnet ring here is good for like 12 pulses per rev. It's picked up by this little Hall effect sensor here, and a 5-volt pulse is sent back as a velocity feedback to close the loop on the DC DRS. So I always wanted to plot the speed curves on these because they were kind of funny. They had a huge hockey stick. So what I'm doing is I'm plotting the speed steps versus frequency of these pulses here, and then dividing by 12 to get my revolutions per second, and multiplying by 60 to get my motor RPMs. So once I get these all figured out, I'll be able to plot this and see if there's a big curve. You can see there's some, right off the bat, there's like 15 hertz steps, and they kind of increase to 20 to 30, and then you get up into the higher speed steps, and we start taking 50, 60 hertz jumps, all the way up to about 1600 hertz. Now I maxed out at 1600 hertz at the encoder at speed step 26. I couldn't get any response beyond that, using my primitive little toy scope here. These are pretty useful. I mean, just to see what's going on somewhere. I wouldn't make fun of these too bad, but I would suggest if you're doing like logic level stuff like this, 5 volts, maybe 10 volts max, it's okay to use it direct. But if you're going to do anything approaching track power, I would get a 10-to-1 probe. There was a note on here somewhere. Yeah, see this max 50 volts peak? That, I believe, was actually 50 volts peak to peak. So track power at 18 volts RMS is going to put you above that. And I think I killed one of these measuring track power. So anyway, that's kind of this little science experiment. So I'm going through the engine. I brought it out here on the layout because it was actually easier to use the legacy remote to keep track of what speed steps I was commanding. And as you know, maybe you don't, with the old TMCC electronics before legacy, they only had 32 absolute speed destinations, and that's including 0. So, and they were just basically motor velocities, and they weren't terribly linear. For some reason, Lionel liked to do sort of a curve to them, and that's what I'm trying to plot here. Like I said, this wasn't as bad as the original Odyssey engines that came out. The hockey stick isn't as severe, but this thing will go flying. I mean, it's almost terrifying. This engine, I gotta weigh it, but I think this is like 30 pounds worth of locomotive to fling around your layout. But anyway, this little exercise was just something fun. What I might do is just plot this in Excel and see what it looks like. Okay, I'm not trying to go off the deep end or anything, but here's the plots of kind of like the encoder frequency versus speed step, motor RPM versus speed step, and finally actual MPH versus speed step. So this is pretty simple, pretty linear math, but you can see the hockey stick. Save for a couple of anomalies here, this could have been my measurements. You can see it's actually not that terrible of a curve. But once you're into this region, once you're already cruising, you can cruise that much faster with a small application of the throttle. So a lot of people didn't like this about the old Odyssey engines. And like I said, this was like the improved speed plot, I think, So I made this sheet I could probably use in the future with some calculations. So I have motor pulses per rev, and that could either be the magnetic encoder or a paper encoder, doesn't matter. Gear ratio, wheel diameter in feet, so you can calculate it, how many times it turns in a mile. And if you plug in these here, the formulas will auto-populate and give you these little plots. So, and you can see the calculations. The motor angular velocity in RPM is the motor frequency divided by the pulses per rev times 60. That gives you RPMs. Wheel angular velocity in RPM is the motor angular velocity divided by the gear ratio. It's pretty straightforward. And the miles per hour is the wheel velocity times 60 divided by the wheel rev per mile. So that gives us our mileage plot. So you see we kind of peak out at 113 miles an hour. On this layout, it's kind of terrifying for an engine that weighs freaking 25 pounds or whatever. So I don't know. Anyway, I try not to kill this project, but I always wanted to do this, and I had a little time today, so. All right, so I think I figured out the IR problem, so I'll be moving on. Had a little time to play with the speed step plotting on here, just for the heck of it. But you can see this is pretty well intact. This is about the time they came out with the semi-smart smoke unit, and you can see it works. We've got 2 chuff per rev. There is a cherry switch down in here. Still trying to decide what I want to do for 4 chuffs. I might make a 3D printed chuff cam and just hog that one out of there and replace it. I got a couple designs. One I used before on my J1A, I kind of glued together, but I have another one, a better design that I can screw together, so I might play around with that. But I'm going to go through and clean up all this wiring. If you heard me gripe before, I'm not a big fan of wire nuts or electrical tape, so there's a little bit of cleanup to do in here. But right now, everything's working. Sounds work. We got dual fat boys here. Here's our S1 sounds. Here's the 8020B board that kind of converts the IR serial comm to wired serial, I guess, for this board to talk with. Here's our Rail Sounds power supply. It's in good shape. I'm gonna make a KD adapter for this here, so that's why I have it apart. I was just going through. I gotta clean up more electrical tape and the wiring just a little bit. Nothing too major, but everything works. I'm gonna go through the gearboxes, clean them up, lube them, whatever it needs. All the running gear seems to be in good shape. So, Odyssey works. I might just keep the Odyssey. I don't know if it's worth putting in, an electric railroad replacement for this guy. I'm almost half tempted to use a vintage EOB setup, but I think I'm just gonna run with what we got here, because this is gonna be a fast running engine, so we'll see. I want to check out what's going on with the gearboxes, so I'm just getting all the electronics out of the way here. Lionel's electronics of this era were quite large and industrial sized, but very robust. I mean, these things have stood the test of time, and I still like the sounds kind of better from this era. They were using Pitman motors back then. I know the Canons, like in that third rail SD9 project I had going, that Canon just catastrophically failed and took out the motor driver. So, I don't know. I like the old Pitmans, they're pretty good. One thing I wanted to do is look up this Pitman part number and see what its max RPM was. Just for the heck of it. So, let's look inside the first gearbox here. I don't expect to see any major surprises. It looks good. It's not chewed up or nothing. Look at the ball bearings in there. Sometimes I like to make sure they're in the correct spot. So actually, it looks pretty good, man. Nice. Yeah, both of them look pretty good. I don't know why somebody greased up the dog bones, but I'm gonna clean that out. Nice. Let's get a little vitamin G in here. Grease looks pretty good in here. I'm just gonna add a little more. These do have grease ports. I might just put a squirt in them from underneath. Get right in there. Alright, so here's our Lionel Chuff Cam, and very typical of this era, it is cracked. and probably been slipping around, giving you some funny chuffs once in a while, but you can see I could actually, yeah, slip it around. So I'm gonna try making, I might actually have a chuff cam already made. Let's see, let's go look. Let's see, let's go, let's visit the chuff department. I might not have any. Here's some of my, I still need to try these somehow. Could probably put one in here, but it would be easier just to put a square printed cam just to actuate that switch. No, I don't have any right now, so I'm gonna have to print a new one. I have one I can screw together. All right, that's pretty typical of the era. Those used to just crack, and then you'd get a little slippy chuff there. See if I can melt it out. Nasty. Here, I got it. All right, now I'll be right back. I gotta extricate it now. All right. There's the old 2 chuff cam. That's the way to get them out. Just blaze a soldering iron across them. So, all right, let's get to making a 3D printed one. I'll do a square cam so I could just keep the cherry switch. Be the quickest way to do it. All right, here's my square cam. See if it works. So here's how the cam halves kind of glue in. So this is my 3rd try. I think this is like a 9mm. I have like a little 1mm radius on the edges, just to like not bounce the switch. Let's try gluing in the other half, see if this actuates the switch well. Okay, I think I got it. Get this out of the way. It's not quite triggering where I want it to, though. I can't remember why I did the glued version of this chuff cam. In any case, it helped come up with the final dimensions for this version, which this is the screwed version I was talking about earlier in the video here. And the screwed version is kind of nice because I can loosen and tighten those screws and kind of adjust the position of the cam lobes to sync the chuff with crank pin position. All right, with the chuff cam all done, then I'm gonna move on to cleaning up some of this wiring. I still haven't decided if I want to change out the old DC DRS here and put electric railroad in here. We'll see. Like I said, I showed you that speed curve. It's not the most efficient, but anyway. I also got to clean up the wiring in the tender. Look how much space is in here. This tender might even be one of the biggest on the layout. So there's a bit to clean up. Get rid of this electrical tape. These, I don't know, these poor man's zip ties here. So we'll keep going. All right, I'm in the process of cleaning up the wiring here. I want to get rid of this electrical tape. Got a little bit of a mystery. This engine from this era had the old ACRG, which is like a serial controlled AC regulator. I mean, it actually put out like 8 volts AC. I gotta verify it. The wiring's correct because everything works. So the whole point of that guy's existence was it ran the semi-smart smoke unit here. So pin 24 serial from the R2LC was distributed around with this brown wire that goes into a wire nut, you know, my favorite thing to have in an engine. and it went to this regulator. It went to the probably somewhere on the DCDS board here, and it also went to the SSMU smoke unit. So I'm just tracing stuff around. I want to trim up some extra slack and get everything to lay down a little nicer. But there's also a missing wiring on the smoke switch, so I want to restore that so I can have that back there in place. So we're kind of going through it. Curiously, the wiring diagram is very close to this. This is what I had kicking around in my stash. This is for an 080 from the same era. And the only reason why I'm using this diagram is that it has the on-off Odyssey board. This was kind of identified by having this little extra connector here, and goes to a Odyssey on-off switch here, which is your cruise. And this has the ACRG board kicking around in here and the semi-smart smoke unit. So I must have had something at one time. I made some notes on the wiring. Curiously, on this smoke unit, I've seen diagrams. I was poking around on the internet, and I saw that the Chuff switch was connected into here, but I think that puff action is actually controlled on this serial line, so we'll figure it out. Also, the power wiring is directly across track power, but there looks to be, it looks like it's half waved and filtered a little bit with this cap. So that's a diode here in the heat shrink. And it kind of goes to one of these headers on the motherboard. So anyway, I didn't give a tour of this engine. I probably should have talked a little bit about Lionel's design philosophy at the time with the TMCC engines. So I don't know, it's pretty basic. Motherboard, R2LC receiver, motor driver in some form, smoke unit, and with the IR tether, that's the serial line, again, coming off this brown wire, pin 24 off the R2LC, drives that IR LED, and then talks with this, I think it's the 8020B board. I forgot what these are. It's been a while since I worked on a Lionel engine. I've been kind of going through my third rail stuff lately. So anyway, we're going to continue on, hopefully get this buttoned up soon, get that switch restored, and that's all. One other mystery was this 5-volt regulator board, and where is it? It's kicking around in here, and it, I don't know, it kind of connects back into the DC DRS here, and I can't remember what that was. I have a DC DRS from my stash, came out of something, I don't know what, so I'm going to look at the pinouts and try to remember what it was for. But anyway, one of the wires got chopped off. I don't know if I did that when I was cutting. I was cutting a wayward zip tie in here. Hopefully it wasn't me, but I don't know. Engine ran anyway up until I started undoing the wiring. So, all right, so I cleaned up the tender wiring. It's not quite a factory restoration, but it is cleaned up. I got rid of all the lamp cord and all the mismatched solid 18 gauge wire in there, so it's a little cleaner. And I also decided to wire the markers and the reverse light together. I thought that looked kind of cool. Not quite sure how often they use those red markers. I think a lot of times it was just for standing still in a yard, but I don't quite know. So everything's about ready to go back together. I think what I'm gonna do is just put it back together, and I gotta print up a Katie mount for this. So it is declawed right now. Gonna put it back together, get that Katie mount printed up, and I'm gonna give it a test run with the original factory Odyssey in here, and see if I can deal with the 20-something usable speed steps. I don't know if I mentioned, but I believe the reason why the speeds plateau out at 113 mile an hour, which is fine, which is more than fast enough for my layout, is because if you looked at the plots I did for the motor angular velocity, measured in RPM, how fast it spins basically, it tops out at 8,000 RPM, I think. So that was the thing there. It's sort of, I don't know, an engineering oversight. I don't know. These original boards, they were not ever speed matched. Like I said, when you were controlling these boards, you actually weren't controlling voltage to the motor. You were controlling motor velocity, basically. So that's how these worked. So with that speed step arrangement translated through the gear ratio, driver size, you're going to get different engine speeds. So it's kind of a drawback of this early Odyssey stuff. So anyway, enough of that. Let me get cracking on putting this back together. All right, so we're out on the layout here, just giving it a quick test run without its shell. A couple things I gotta fix. I'm going to probably make a nice power jumper. This thing only has a total of 4 pickup rollers, and they're not tied together because we're running this IR tether. My IR tether box is working. It's going around the layout without dropping sound or anything like that. So got a little bit of problem with the tender. Shell's got a little rattle to it. Gotta fix that. Tender shell's gonna come back off anyway to put the power umbilical on here. So, and that's where we're at so far. Well, all the screws are tightened up on this tender deck, so I'm going to try to run a bead of some goop here I stuck in this syringe and see if I can seal this little gap. See if this works. If it's going to come out of here or what. Look at that. That looks pretty precision. Oops. Look at that. Sorry about the crappy filming. Yeah, I'll give that a try. All right, the engine's going back together. So this is my solution for a power umbilical, I guess. So a nice thing is it's power and ground, and it's keyed so it can't be plugged in backwards. So we'll put this back together. Gonna get the cab light installed there. And then we'll give it a nice hot test run. All right, so I got it back together here. There's my 3D printed IR holster. My power plug. What a beast of an engine. I'm gonna put this thing on the scale real quick. Wow. 13.5 pounds. Holy moly. All right, so there it is. Let's give it a test run here. I got a bit of a train on it. Nothing too fancy. I don't have any decent cars really to run with this. I have some P70 heavyweights and a lot of head end stuff. So anyway, this is a nice load for it at least. This only had a horn, so I'll refrain from using the whistle. Let's see how this runs. First speed step's pretty quick. Sucker's loud. So I think so far the mods and repairs and the semi-factory restoration here has been successful. Engine's running. I've got the original on-off Odyssey in here, which would have been Lionel's second version. And like I demonstrated with the spreadsheet, you know, and the measurements I took, the speed curve is a little chunky on these guys, and from this era, you know, there's no effort made to like calibrate the speeds based on gear ratio and driver size. But Lionel didn't get into doing that until Legacy. So I don't know if you noticed, but when it was running on the other side of the layout, on the fireman's side, I'm missing a couple of these ashpan grills or whatever. So I'm working on that right now. We'll get back in the shop. I just wanted to take this out for a run, see if everything worked good. And I got the correct engine code set for it. One bummer with this thing is the horn is an aux 1 6 function. When the engine is running, let me back it up here, and you're using the any aux 1 function, it'll flash the headlight. I don't know if you can see that. That's just the way they program this. I guess they were afraid of putting a horn on the actual whistle button. So these never did have a whistle, but anyway, that's about it for now. I think that was a good test run, and we'll get it back in the shop and do the final cosmetics on it. So here's my 3D printed replacement ashpan grill. As you can see, it was only really missing one. There's 3 different sizes here. These 2 are the same, so I was able to dimension the replacement off this one. The only problem is I don't have this nice square screen mesh stuff. I don't know what I'm gonna do about that yet. For some reason I had another short one here. It was just kind of hanging. So I found this screen material in my scrap box, and it was probably left over from years ago my first Q2, I had to rebuild the aftercooler assembly, and I got this from P&D, and it looks more like almost like expanded metal versus Lionel's like perforated screen there. But I think once it's painted up behind these frames, I don't know if you'll be able to tell the difference, especially at the speeds I'll be running this at. All right, here's the effort so far. I got a pretty decent color match. That's my old polyscale Brunswick green with a little bit of reefer yellow added to it just to match the Brunswick on this engine here. So I'm gonna go ahead and touch up these silver flutings here. So there it is, my homemade replacement for one of these ashpan vents or whatever these are. I think I'm gonna quit while I'm ahead here. Looks better than what I started with, that's for sure.